I'm Giacomo Sgotti
And I am Piero Studio.
and we are from Politecnico di Milano, and today we will show you our system proposed for the Restart project, the WatchEDGE, and for wildlife monitoring. And it will take place into Parco di San Rossore in Pisa. And let's start from the cameras.
Yes, starting from the cameras, we are currently in Pisa, as my colleague had mentioned. We are currently in Fornita, and this particular spot happens to be where animals are most prominent, or where they usually frequent. And based on this location, we've decided to set up our own camera systems. As you can see here, the one on top is actually designed by our collaborator, Sensor ID. And the one below is possibly created by Politecnico di Milano. The objectives are the same, both models imbued or embedded with the object detection model detect three classes of animals, which are the boars, wolves and deer.
These cameras are connected to the internet thanks to our Wi-Fi system that they connect directly to our internet access point there. So follow me. This is the access point we were talking about that spreads the internet access to the nearby area.
So this is the edge part of our project. As you can see here, this is where we are receiving currently our data, and we are seeing the inferences that are made by our model. In this case, we are seeing the wild boars that are being detected. This part also includes one of our projects that we are developing, which is the Raspberry Pi based model. It currently supports 650 nanometer camera and is equipped with, again, a monocular camera.
And the access point we were talking before is connected to our CPE, SD-WAN CPE, that provides internet connectivity to all the local LAN devices. And thanks to dual WAN connectivity that is provided from one side from the 4G network through this router 4G, and from the satellite network that we are gonna see later. The access network, both the access network are continuously monitored in order to choose dynamically the best connection towards a cloud that is possible.
Right.
And this is the satellite antenna that we were talking before, that is one of the two one access networks.
And here we can see our custom power supply, the one that is currently powering our Raspberry Pi camera. As you can see here, this is our battery system that we have designed. We can see the charging system, and it is equipped also with a battery management system that keeps our batteries safe as well as balanced during both charge and discharge, even when put in the wild.
Thank you for your attention, and see you at our next demo.
Good morning everyone, I'm Cristian Grasso. I'm an assistant professor at the Department of Electrical, Electronic and Computer Engineering of the University of Catania. In this video I will present the activities carried out within the WatchEDGE project by the EMIP, Aerial Monitoring Image Processing Laboratory, of which I'm a member together with my colleagues Professor Giovanni Schembra and the PhD student Andrea Caruso. The WatchEDGE project aims to develop automatic environmental monitoring systems based on the use of artificial intelligence to monitor and preserve not only animals but also the habitat where they live. To achieve this, the activities of our group within the project can be summarized in 5 points. Automatic creation of aerial dataset and subsequent aerial recognition of animals and plants, thermal analysis, multispectral analysis, and photogrammetric reconstruction. To carry out these activities, we used a fleet of UAVs available in our laboratory. In particular, we have 4 DJI Mini 3 Pro used as sensing UAVs for image and video capture, a DJI Mavic 3 Pro with an RGB camera with higher resolution compared to the previous drones, a DJI Mavic 3M characterized by an integrated multispectral camera in addition to the RGB camera, and finally we have 3 DJI Matrice 350 RTK UAVs capable of carrying an additional payload of up to 2.7 kilograms. For the image and video capture, in addition to the integrated cameras of the UAVs, we used a DJI Zemius L2 camera equipped with LiDAR technology, which allow the possibility to implement photogrammetry, a DJI Zemius H30T thermal camera, and a Megasense WatchEDGE 3M multispectral camera. These cameras, mounted on board the DJI Matrice 350 RTK, allow us to expand the analysis that can be carried out during the UAV flights over the area of interest. In particular, in the Emiliano San Rossore Massaciuccoli Park near Pisa, in Italy, chosen as the project's experimental area. Regarding the first 2 activities, so the creation of the aerial dataset and the aerial recognition phase, several animals present in the park were considered. For example, the wild boars, fellow deer, wolves, horses, and the mucco pisano. But we also decide to evaluate the possibility to create a dataset regarding the vegetation. For example, the pine tree in the area, some of which are affected by the Cocciniglia tartaruga, as well as other medicinal species found in the Lame area of the park. To do this, we implemented a system that, upon receiving the video in real time coming from the UAVs during the mission, reduces its resolution depending on the bandwidth available on the channel between the UAVs and the ground server, improves its quality by removing possible noise, and extracts frame. These frames are then sent to an application deployed in the ground server that uses YOLO-E. YOLO-E is a semantic recognition algorithm that is able to create a dataset with the images of the subject of interest. This dataset in the second phase is used to train a recognition model for a specific class of individual. So we can create a model that is able to recognize wild boars, another for fellow deer, and so on. These models are lighter than the YOLO-E based one and can be executed on Raspberry Pi or Jetson Nano mounted on board the UAVs. In this way we can perform the inference phase during the missions of the UAVs. We can recognize species, count the individuals, and study their behavior. The result of this activity lead, in the case of the whiteboard, in the possibility to recognize and count them as shown in the video. As already said, another activity involves thermal analysis using the DJI Zemius H30T camera that allow us to perform not only night missions within the park, since animals can be identified by their body temperature, which is clearly different from the surrounding environment, but also to understand if some individuals show anomalies compared to the other, for example, if they have a higher or lower temperature than the average of other animals of the same species. Other analysis regarded the use of multispectral cameras. This type of analysis makes it possible to evaluate the healthy status of vegetation thanks to the possibility to capture not only images in the visible range, the classic RGB, but also in frequencies that are not visible to the human eyes, such as red edge and near-infrared range. Evaluating some parameters calculated using software like DJI, it is possible to detect whether a plant that appears healthy may actually have problems that have not yet manifested. Finally, we also carried out photogrammetry missions for 3D reconstruction by capturing photos and generating point clouds using the DJI Zemius L2 camera, with the goal of identifying specific features of a particular area of the park, features that may not be visible except from an aerial view, studying the terrain and vegetation height variations, and even creating 3D virtual reconstructions of buildings within the park, as shown in the video.
So we are here for the final setup of the University of Pisa trial in the framework of the WatchEDGE project. And we are in the park of San Rossore, in the middle of nowhere, and we are here to demonstrate the feasibility of the recognition of wildlife situation in the territory. And this is something that we have done deploying a distributed artificial intelligence platform that is composed by smart cameras, totally autonomous, a gateway that has some processing capability and again is totally autonomous, and edge computing that is powered by the electrical grid. The communication among this island and the rest of the world happens thanks to several networks that are wireless networks, and particularly satellite communication provided by Starlink and a Wi-Fi connection provided by Regione Toscana. You know that here we have the possibility to show the integration of computing and communication. Storage, computing, communication is becoming a unique platform thanks to the transformation of telecommunication that we want to demonstrate here. It is interesting to have a specific goal that in our case is to work during night and during day for the acquisition of images and short videos of the animal here in the park. This is a typical example of the transformation of some specific domain thanks to the adoption of ICT, information and communication technologies. In the past, there were several volunteers that were here with binoculars to try to collect the presence of the animals, counting them a couple of times during the year. And later on, there were some trail cameras that were used in fixed position to collect some of the images during night and during day. You can imagine the difficulties in collecting the SD cards, changing the batteries to obtain this type of information. On the contrary, thanks to the WatchEDGE deployment, we had the possibility to have smart cameras. We call smart since they are able to have acceleration of artificial intelligence embedded in the device, and of course we had to use very special wireless communication to reduce the power consumption, even in a hostile environment such as the wood of the Park of San Rossore. Here we use Hello, that is a version of the 802.11 that we know Wi-Fi, but there is a special standard that is called AH, where you are working under 1 megahertz of frequency and where you can collect the data thanks to this low power communication. So we call them smart cameras since they have embodied artificial intelligence. You know that artificial intelligence has 3 main ingredients that are data, architecture for the neural networks, and hardware accelerator. But of course, there is no artificial intelligence without communication, and in a hostile environment such as the one that we have here, everything is more challenging. And for that reason, we use Hello, that is 802.11ah, a very special Wi-Fi standard where it is possible to have symmetrical communication within the wood of the Park of San Rossore. The cameras are connected with these low-power wireless communication networks. Then there is a point-to-point communication links running under 6 gigahertz, where we have the possibility to collect the information from the camera and bring it to the edge of this island, and from the island we go to the rest of the internet thanks to the Starlink satellite communication. So there are here 3 types of wireless communication that are running simultaneously to get all the information and put them in 2 types of databases that are within our edge computer. There you collect the images, and also we collect the data from the very detailed analysis of everything that we measure: temperature, humidity, temperature in the box, working of the GPU, CPU, as will be shown by Professor Davide Adami in his part. So I think that is a demonstration of a cloud continuum that for us goes from the extreme edge of the network to the far edge, to the edge, and even with the collaboration of the data center, the green data center of the University of Pisa, that is even located in the same park of San Rossore. So we have this opportunity to deploy artificial intelligence with the cooperation among the different components that are also synchronized thanks to the use of GPS, and also the timing is extremely relevant in this deployment to have some inference from the data and from the multiple sensing, the collaborative sensing that we have in our deployment. So all the information collected are very relevant data set that can be used together with the data set of the images to, of course, verify that we are able to classify automatically, thanks to the artificial intelligence in a supervised learning approach, the images, but also to have the possibility to orchestrate the function of the networks, thanks to the fact that we have a status, a very detailed status about throughput, delays, and even the temperature or humidity that is collected around, to be able to allocate resources in a proper dynamical way.
A Grafana-based interface that has been designed and implemented for the WatchEDGE project, and it allows users to monitor the device that are part of a test bed. First of all, it provides information about the last detected animals, and here there is the image, and there are also information about the power consumption and power produced by the different panels. Each device is characterized by its main performance parameters and also about data that are related to the temperature. As you can see here, there are a lot of information that allows the user to have a complete knowledge about the status of the system. Last but not least, there are also data about the traffic exchanged by the device, and in particular about each connected device that has been deployed in the San Rossore Park. So at the end we can say that this is a very intuitive and user-friendly interface that allows a complete monitoring of the device that are connected to the test bed, and this is very important because system administrator may have full updated continuous knowledge about the status of the system.